This is a continuation of Lesson 2, Section 1.5, dealing with factoring polynomials. This particular portion of the video is going to focus on what if you have two terms. And when you have two terms, there are really three different patterns that you need to think about. So let me open up a new page and show you those patterns. The three patterns are a difference of two squares. And so when you're thinking about trying to identify the difference of two squares, difference of two squares. One clue that you have a difference of two squares, first of all, is that typically you're going to see an exponent of 2 on the variable and a minus sign between them. Remember, a subtraction problem is known as a difference. And it always factors as A plus B, A minus B. And it's just one of those patterns that you're going to have to learn and know how to factor it. There's also a pattern for what's called the sum of two cubes. We know it's a cube when we have an exponent of 3, and it's a sum if they're being added. And it's a little bit different, okay, when you factor it. But you have A and B. What did you cube to get A cubed? What did you cube to get B cubed? Plus sign between them. Then to get the second pieces, you square the first term, so A squared. To get the last term, you square the last one, B squared, and then you multiply them together to get the one in the middle, and it's a minus and a plus. And again, guys, that's a pattern. It's a formula that you're going to have to learn. And then finally, the third one is a difference of two cubes. Again, we recognize it as a cube because typically you'll have that exponent of 3, and instead of having a plus sign, you'll have a minus sign. Difference is subtraction. So again, it really follows a similar pattern, basically the same pattern. The only difference is the signs that you use. So to cube A, or what did I cube to get A cubed would have been A. What did I cube to get B? B. Minus sign between them. Square the first term, square the last term, multiply them together, and for the difference, it's a positive and a positive. Okay, so those are the three patterns and things that you want to look for whenever you have something where you have two terms and you're trying to factor it. Don't forget the first step, though. We still always want to look to see, do we have a greatest common factor? So if I'm looking at question 23 from section 1.5 in your textbook, then I notice that 16 and 100 can both be divided by 4. So I have a greatest common factor of 4. So I'm going to factor that out first, which leaves me with 4x squared minus 25. And then I need to see if this expression in the parentheses will factor or break down further. And I notice I have two terms. It is a square and a minus sign between them, which again makes me think, it might be a difference of two squares. If you think about the number 4, 4 is a perfect square. It's 2 times 2. 5 is a perfect square, or 25 is a perfect square because it's 5 times 5. So it does fit the pattern for the difference of two squares. So we draw the parentheses. To get 4x squared, I would have multiplied 2x times 2x. And to get 25, I would have done 5 and 5. One's a plus, one's a minus. And there it is. All right, number 25. Again, I'm looking at it. I don't think it has any numbers in common. It doesn't have any letters in common. So this particular one does not have a greatest common factor. Again, I noticed the exponent of 2, which makes me think of a square. I have a minus sign between it. So I have to decide, is 121 a perfect square? And you may not know, but 121 is 11 times 11, or 11 squared. 169 is 13 times 13. So in this case, both of those are perfect squares. So again, following the pattern, draw our parentheses. To get 121, I did 11 times 11 and p times p. To get 169, I did 13 times 13. One's a plus, one's a minus. And there it is. Question 37, when I look at it, I notice, I have an exponent of 3. I don't think I have anything in common. So this particular problem does not have a greatest common factor. Okay, but I have a cube and a plus sign. So it makes me think of the sum because I got the plus sign. Okay, and it makes me think of the cube because I have the exponent of 3. And so I need to decide, is 216 a perfect cube? And again, you may not realize that, but 216 is 6 times 6 times 6. So it is a perfect cube. So I should be able to factor this using the pattern that I mentioned to you just a minute ago. So let's see. Let's break this thing down. To get x cubed, I would have cubed x. To get 216, I cubed 6. Keep the sign. To fill in the second parentheses, square the first term. So x times x is x squared. To get the last term, you square the 6. So 6 times 6 is 36. To get the middle term, you multiply the two terms together, 6 times x. And then one's a minus and one's a plus. The biggest thing there is learning the pattern and making sure you get the signs correct. Okay, one more. And again, looking at this one, 64x cubed minus 125. Again, if I'm thinking about it, it doesn't appear to have a greatest common factor. Again, I think about it being a cube because I have that exponent of 3. And I have a minus sign between them. So this one's going to make me think of the difference of two cubes. And again, I'm thinking about the difference because it has a minus sign between them. Okay, you may not realize it, but 64 is a cube. It's 4 times 4 times 4. And 125 is a cube. It's 5 times 5 times 5. Okay, so I'm going to put my two parentheses down here. Okay, to get 64, I would have cubed 4. To get x cubed, I cubed x. To get 125, I cubed 5. And you keep the sign, so it's a minus sign. To fill in the second parenthesis, square the 4x. 4 times 4 is 16x squared. To get the last term, you square the 5. 5 squared is 25. Multiply them together. 4x times 5x is 20x. And they're both positive. And there's how you factor the difference of two cubes.